Hello, everyone. In the previous video, we took derivatives with respect to x. So our functions had x in them, and that's it. That's not the case, in the real world. Functions could depend on other functions of x. So this is the purpose of this video, okay? It's called the chain rule. And what we're going to do is we're going to do similar things as in the past video, but with a little twist. Let me show you how. So if we compare what I'm going to call the chain rule, or what's called the chain rule, with what we did before, they're very, very similar, extremely similar. Let's take, for example, the sine function, okay? Actually, the secant is maybe a little more interesting. So let's look at the secant function, and let's not think of this as x, let's think of it as just a box. So the secant of something prime, it's supposed to be an x here. There it is. It's the secant of the box, tangent of the box. Now I'm saying, okay, here I could have a function of x. In other words, u is a function of x. So what's the derivative of the secant of that function? Let's follow the box analogy. Here's a box, here's a box, and here's a box. They're basically the same. In other words, I carry the box around. Secant of x prime is secant x tangent x. Secant u prime is secant u tangent u. But the difference is at the end, I multiply by the derivative of that u, of the argument of the secant. Okay? Quick example. So again, we know how to take the derivative of the secant of x. This is secant x, tangent x. Now, what if I have the secant of x to the 1/2? This is the u I was talking about. Again, we do the same. We just take the derivative of the secant of that thing, like we're taking the derivative of the secant of x. So that will be secant of the thing, tangent of the thing, times the derivative of the thing. You see, now this is secant square root of x, tangent square root of x, times derivative of x to the 1/2 is 1/2 x to the negative 1/2. And now we can simplify things. X to the negative 1/2, bring it down and make it a square root. There's the answer. Okay? So as you can see, this is here and there. This is here and there. The only difference is we multiply by the derivative of the function of x, or the argument of the secant. All right? Let's work out some problems so we can, again, these, by the way, are still apply. And of course, the derivative of a constant is 0. Okay, and let me add here the derivative of a or mx plus b is just m, the slope. Okay, let's look at this problem. So here, what do we have? We have something, again, I'm not concerned with what that thing is, just something to a power, a function. In this case, t is my variable, not x. And it doesn't matter whether it's t, u, v, it doesn't matter. As long as we know what our variable is, we can easily take derivatives using those rules. So this is, again, similar. This is a power rule. The constant here is 1. Some function of x, in this case, t, to a power. So we do the regular power rule, then take the derivative of this function here. Okay, so and this is the u, right? So the derivative here, y prime, is the regular power rule. You drop the power to one less power times the derivative of this thing right here. See? So now here we have 2/3 t squared plus 3 sine t. 2/3 minus 1 is -1/3. Derivative of this is the derivative of this plus the derivative of this. So derivative of t squared is 2t plus 3 comes along for the ride. Derivative of sine t is cosine t. And we are done. We cannot simplify this anymore. Now you may want to bring this down to make it a positive exponent, but that's trivial. Okay. Okay. Here we have e to the 3x plus sine 4x. All right. So again, we need to use the methods that we learned, and at the end, we multiply by the derivative of the arguments of these functions. So here y prime, derivative of e to something, is itself times the derivative of that something. See that? That's, if you call this u, then you're taking u prime right there. Plus sine of something, the derivative is the cosine of something, times the derivative of that something. See? That's a chain rule. Derivative of 3x is just 3, and here's e to the 3x, plus derivative of 4x is 4 cosine 4x. Answer. Dx minus 2 to the 1/2 plus cosine 2x. Again, here I have something to a power automatically in my mind. I should think power rule, and here just a regular trig function. So y prime equals power rule for this one, for the first term. I have something to a power, so the power rule says drop the power. That's something to one less power, then times its derivative. Plus derivative of cosine 2x. Well, the derivative of the cosine is negative the sine. Now, because we have 2x here, we got to take its derivative. Right? This is the same as cosine u prime is negative sine u prime. If you consider the 2x as u, there it is. So 1/2 3x minus 2. 1/2 minus 1 is -1/2. Now times derivative of 3x minus 2. That's a straight line. The derivative is 3. Here we have derivative of 2x is just 2. Bring it to the front, combine it with this minus. Simplify one more time. 3/2. You can bring this down. Okay. Again, here we have power rules, because again, if something to a power, first thing, it doesn't matter what that something is. We automatically go for the power rule. And then we worry about it when it's time to take its derivative, how we take its derivative. Okay. So just simple power rules. So y prime is drop the power, that's something to one less power, times the derivative of that something. That finished the first term. Minus second term now. Drop the power. That's something to one less power times its derivative. Here's a half. X squared plus 2x to the negative 1/2 times the derivative of x squared plus 2x. Well, derivative of x squared is 2x plus derivative of 2x is 2. Okay, again, 2x is a straight line. We grab its slope. Minus 3/2 x minus 4. 3/2 minus 1 is 1/2. Derivative of x minus 4 is just 1. Again, straight line, slope 1. So maybe we can bring this down and then put this on top. Minus 3/2 square root of x minus 4. There is the answer right here. You don't have to simplify it anymore. This is good. All right. Now this one, in a way, you know, we gotta apply some natural log properties. Okay. So we don't know how to take the derivative of a fraction yet. That will come later when we talk about the quotient rule. But the nice thing about the natural logs is you can take a fraction and make it into a sum or a difference, and you can do some maneuverability right here to simplify it. So remember now, natural log of something to a power, we bring that power to the front. Okay? So that's the first thing we do. We bring this to the front. Now, also I know the log of a fraction is the log of the top minus the log of the bottom. So here's the 2, parentheses. Let's do log of top minus log of bottom. Now, I have here the square root of x minus 1. I'm going to go ahead and write it as x minus 1 to the 1/2. I can't do anything with the first term, but I can bring this to the front according to this right here. So here's 2 ln of x squared plus 4 minus 1/2 ln of x minus 1. And now I've simplified it as much as I could, so I can now take derivatives. So y prime equals 2 comes along for the ride. Derivative of this, okay, it's 1 over x squared plus 4 times the derivative of x squared plus 4. Okay, minus 1/2. Derivative of ln of x minus 1 is 1 over x minus 1 times the derivative of x minus 1. Chain rule. Ln of u prime is 1 over u prime, or u prime over u. Okay. Here's the 2. What's the derivative of x squared plus 4? It's just 2x plus 0 minus 1/2 1 over x minus 1. What's the derivative of x minus 1? It's just 1. So simplify one more time. There is your answer. All right. Similar thing here. I'd like to simplify this. Okay. And then the rest doesn't need to be simplified. So y equals 3 sine 2x plus 2 to the negative x minus, again, the log of a fraction is the log of the top minus the log of the bottom. Okay. Here I see two things multiplied. I see a 4 multiplying an x with the log. Also remember that the log of a product is the sum of the individual logs. One more step. Here I have log 3, 4 plus log 3x minus log x minus 1. Okay, we can let the minus in now or later. Doesn't matter. Let's let it in. Now take derivatives. 3 sine 2x. 3 comes along for the right. Sine 2x, derivative of the sine is the cosine of 2x times the derivative of 2x. Plus 2 to the negative x. The derivative is the ln of 2 times itself times the derivative of negative x. Because the power is not just x, it's negative x. Minus the derivative of the log 3 of 4. This is a number. Okay? So it's 0. Plug it in the calculator, you get a number. Minus log 3 of x. So this is 1 over ln of 3 times x. Plus log 3 of x minus 1. This is 1 over, actually it's ln of 3 of x minus 1 times the derivative of x minus 1. Okay. Let's simplify. Derivative of 2x right here is 2. 2 times the 3 out here is 6 cosine 2x. Plus, actually it's minus. The derivative of negative x is negative 1. So this changes the sign here. This one stays the same. And right here, what's the derivative of x minus 1? It's just 1. So it'll be plus 1 over ln of 3 times x minus 1. There is the answer. What? Again, here we have a power rule on the first one, and then a tangent on the second. So let's look at y prime. Power rule. Drop the power to one less power times the derivative of the function plus derivative of the tangent is the secant squared. So that's secant squared of 2x plus 1, 2x squared plus 1 times the derivative of 2x squared plus 1. Okay. So this is 1/2. This is 4x minus 2 to the negative half. Derivative of 4x minus 2 is 4. Again, straight line with a slope of 4. Plus, let me do this first. Derivative of 2x squared plus 1. That is, there's a 2 there. It comes along, and I drop the 2. 2 times 2 is 4. Okay, let's just do it here. Let's just do it. 2 times 2x to the 1 power plus 0. So that's 4x. So this 4 and the 1/2 gives me 2. 1 over the square root of 4x minus 2 plus 4x secant squared 2x squared plus 1. That's it. We cannot do much with it. Right? 4 tangent ln of x. Right? Again, we have tangent of a function of x. So we got to use the chain rule. So y prime, 4 comes along for the ride. Derivative of the tangent is the secant squared of that thing times its derivative. What's the derivative of the natural log of x? It's just 1 over x. So it'll be 4 secant squared ln of x over x. And this is the answer. But again, here we have power rules. So let's go ahead and apply them. Drop the power. Let's drop the power first. One less power times the derivative of this. Plus, again, something to a power. We drop the power. That's something to one less power times the derivative of that something. Here we have negative 2, 3x squared minus 4x plus 2 to the negative 3. And now I have here the derivative of this. Well, the derivative of 3x squared is 3. Drop down to 2, x to 1 less power. This is a straight line. Its derivative is negative 4. Plus 1/2 x squared, x to the 4 plus 2. 1/2 minus 1 is negative 1/2. Now, what's the derivative of x to the 4 plus 2? The derivative of x to the 4 is 4x cubed plus 2 is 0. So simplify a little bit here. Maybe we can bring this down. Give it a positive exponent. And here I have a negative 2 times 6x minus 4. This 4, since 4x cubed plus 0 is just 4x cubed. This 4 and the 2 cancel out, give me a 2 x cubed x4. Then bring that down, make it in the denominator as a square root. There's the answer. Right? So this is the chain rule. Now we've done, for example, how would we now do x minus 4 over sine 3x, or tangent x ln of x squared plus 4? How do we take these derivatives? Okay. Yes, we see we need to use the chain rule here, for example, and here, but we need to develop new techniques. So in the next section, and the one after, in the next video and the one after, we're going to do the product rule, and then the quotient rule. Where basically we can do these things according to those rules and take derivatives of two things multiplied, two things divided, okay? While also paying attention to whether we need to use the chain rule or not. Let's hope to see you in the next set of videos. That's it for now. Thank you.